All right, these are the answers to our Calc BC topic so far. The first one's an arc length. They give us the curve x to the fourth. They want to know which of these would give us the arc length from 1 to 5. They're all integrals 1 to 5, so that doesn't help. It's really got to remember the arc length formula, which is to integrate the square root of 1 plus the derivative squared. So I need to find 1 plus the derivative of this squared. The derivative of that's 4x cubed. If you were to square that, it would be 4 times 4, 16, x cubed times x cubed, which would be x to the 6th. So the one that does that is D. Number 7 gives us a differential equation, tells us that we start at 1, -2. We want to get to 1.4 using 2 equal steps. So we make our table here, dy dx, delta x, delta y. Okay, go across. Keep ourselves organized here. We're starting at 1, -2, and we're going to get eventually to 1.4. And we're going to do that by going 0.2 forward. Okay? So at 1, -2, if I were to put that in, 1 minus -2 is 3, minus 1 is 2. 2 times 0.2 is 0.4. Add that to -2, and you'll get -1.6. All right? So if I add 0.2 to the x, to add 0.4 to the y, this is my new point. So now I'm going to jump from this point, put this in. 1.2 minus -1.6 is 2.8, minus 1 is 1.8. 1.8 times 0.2 is 0.36. Add that on to -1.6, and I get a -1.24, and that's B. They expected us to do that without a calculator, so this right here, to get from here to here, what I did was I knew 2 times 2 times 18 is 36. So 2 times 1.8 would be 3.6, and then the point just means it moves over 1. So that's kind of how I did it in my head. We get 14, and this is not arctangent, which is the temptation here. If that had been a plus, then this would be our answer. But because it's a minus, not that, okay? And so then I have to think, well, maybe this is like partial fractions. This is x plus 2, x minus 2. So let's rewrite this as a over x plus 2 plus b over x minus 2. Okay, multiply everything by that common denominator. We're going to get 8 equals a times x minus 2 plus b times x plus 2. All right, let's let x equal 2. That's going to give us 8 equals 4b, which means b equals 2. Then let's let x equal -2. We get 8 equals -4a, so a equals -2. All right, so now we're going to integrate we changed this into a -2 over x plus 2 plus b2 over x minus 2. And that's going to give us -2 natural log of x plus 2 plus 2 times the natural log of x minus 2. Okay? Plus c, of course. Now, that's nice. We look and we see if that's what we see over here, and unfortunately, that's not quite what we're seeing, right? And so they've rewritten it a little bit. What they've done is they took the 2 out, right? So 2. And then they rewrote this as natural log of x minus 2 minus natural log of x plus 2. And with the log rule, when you subtract 2 logs, you can combine it by taking this divided by that. So we're looking for 2 natural log of x minus 2 over x plus 2 plus c, which is c. Okay. This one gives us an arc cosine, wants us to find the derivative. Now, we've emphasized that really arc sine, arc tangent are the ones you really should focus on, and that's still true. This one's from quite a while ago. Here's the deal, though. Just like with regular derivatives, the derivative of cosine is the negative, sine. When you do arc cosine, it's simply the negative of arc sine. So arc sine would tell you to go 1 over the square root of 1 minus whatever's inside squared, so x squared squared, times the derivative of that, which is 2x. So that would be arc sine. Arc cosine is simply the negative of that. And if you look at your options, you'll see that B fits that perfectly. So arc sine, if that had said arc sine, you would pick C. Arc cosine, simply B. But again, I would only really don't get too excited about anything other than arc sine, arc tangent. 22 here gives us quite a bit of information, a table. It tells us that the integral from 0 to 4 of f is 8, and then wants to know what's going on with x f prime. So this is a by parts, all right? We've got a u, we've got a dv. Our u is going to be x, which means du will be dx. Our dv will be f prime x dx, which means v will be f of x, okay? So then this integral here, or this integral right here, will equal x times f of x minus the integral of f of x dx, and we're doing that from 0 to 4, all right? Now, this is where it gets a little tricky. If we were to do this, I think probably it'll be easiest for you to understand if we kind of split it like this and like that, okay? Because we're not going to be able to integrate this into an expression that we could then put 4 into all of it and minus 0 into all of it, and that's probably what got you a little confused here. We can do that here for the first part, but not for the second. Now the second part they already told us was 8. So this is going to be minus 8 on the back end. But on this first part, we're going to do 4 times f of 4, which is negative 3, minus 0 times f of 0, which who cares, that goes away. So we end up with negative 12 minus 8, which is negative 20. So this is definitely a tricky kind of problem. I have seen it from time to time, but it is on the trickier side. The by parts is one thing, you know, to kind of notice, but then being able to navigate that can be a little hard. All right, then this one here is doing this kind of Riemann sum on this 1 over n, and as they increase n, they keep getting a bigger and bigger number. And they're using that to approximate 1 over x from 0 to 1. And they want to know which of these is true, and then you have a lot of kind of confusing things. Now, I would just come back to what they were doing. They were trying to integrate 1 over x from 0 to 1. If we integrate 1 over x, we get natural log of x, right? And if we do this, we get natural log of 1 minus natural log of 0. Now, natural log of 1 is 0. But the natural log of 0 doesn't exist. It's like a negative infinity. So we get 0 minus negative infinity, which is infinity. This is going to diverge, right? This is going to get bigger and bigger and bigger and bigger over time. So the limit does not exist, not because this doesn't approach 0, because it's not approaching 0. That's getting bigger and bigger. And it doesn't because it's a sum of an infinitely number of positive numbers. No, we can add an infinitely many number of positive numbers and still get unlimited. It doesn't exist because the natural log of 0 doesn't exist, right? And again, kind of a tricky one to navigate, but if you come back to what we were talking about in the first place, maybe that would have helped guide you on that one.